Hey everyone, so we've got our second partial fractions video. This one's going to be a lot shorter. Just going to do a couple examples here. So we talked about those four cases yesterday: linear distinct, linear repeated, quadratic distinct, quadratic repeated. So I want to do a couple where we have repeated factors. And let's take a look at example one. So I've already kind of got this one started. We had our original problem that we were trying to break up is x squared plus 1 over x times x minus 1 squared. It's already factored out for you, and we see that we have a linear factor x and then a linear factor repeated as x minus 1 is squared. So to split it up, we get a over x plus b over x minus 1 plus c over x minus 1 squared. Any term that's repeated, we kind of build up from first power to second power to however many it has. Each gets its own fraction. So when we get our common denominator, we're going to be multiplying, and you want to be careful. What you're looking to make this denominator, x times x minus 1 squared. So for a, what is missing in this fraction, I already have the x, I just need the x minus 1 squared. I don't multiply by x minus 1 and then x minus 1 squared. You just want to multiply by the piece that it's missing to get the entire denominator, x minus 1 squared. B is only missing a single x minus 1, and it's also missing the x. So we do x times x minus 1 for B, and then for C, I have x minus 1 squared, I just need x. So c is multiplied by x. Okay. Now, what I want to do here is show you a different method. Instead of going through and getting that system, there's another way. I've heard it called the cover-up method. And essentially what it's saying is, like, when we have these in factored form like this, I have a really easy way to make these chunks of the equation into zeros. And so what I'm going to do is start off by letting x equal 1. And if I let x equals 1, I want to see what happens to this equation. On the left side, I get 1 squared plus 1, so I get 2. 1 squared plus 1 equals, on the right side, when I have x equals 1, the first term here becomes 1 minus 1 is 0. This is just 0. Plus, here I have 1 minus 1 is 0, so I'm going to have 0 in that term, plus c times 1, or just c. Well, look at that, we just solved for c. I now know that c equals 2. I'm going to do the same with a different number for x, let x equals something, to make another term equal to 0. Well, 1 minus 1 made it 0, but we already used 1, so now I'm going to use x equals 0. We'll make this one and this one 0. So let's see what happens. Let x equals 0, and I get on the left side 0 squared plus 1 is just 1, equals, here I would have a times negative 1 squared, or just a times 1, plus 0 plus 0. Oh, look at that. A equals 1. I've already got A and C. Now here's the thing. I don't have B. And there's not another number I can choose to make any factor 0. I've already taken care of x minus 1 by using x equals 1. I've taken care of the x's by using x equals 0. So if that ever happens, we just get to pick any other value for x. Let x equals 2, maybe. All right, if I have that, I'd get 2 squared is 4 plus 1 is 5 equals, and here I have a times 2 minus 1 squared, so that's just going to be a again, plus in my second term, I'd have 2 times 1, so I'd have 2b, and in the third term, I'd have 2c. And what's nice is I already know a. I know a is 1. 5 equals 1 plus, I don't know b, but I know c is 2. And as I try to finish solving this, 4 and 1 is 5, so I actually get 0 equals 2b. So now I know that b equals 0. And so I have my answers, a, b, and c. So I can write my final answer here as 1 over x plus 0, so I'm not going to write the 0 over x minus 1, plus c, so plus 2 over x minus 1 squared. So I split that up. So a lot of times that's nicer than the matrix method, or like solving the system, and especially when it's tough to get the terms all figured out in terms of going on the hunt for your coefficients. All right, so let's do example 2. Here we have a repeated quadratic. So I'm going to I have a linear term, so it still gets just a over x, plus, then for my repeated quadratic, I do it once to build it up, so I'm going to have over x squared plus 1. And if you remember, for quadratics, I use like bx plus c. And then I have to do another one for x squared plus 1 to the second. So I'll use dx plus e. Okay. So let's get our common denominators. I'm going to have 1 equals a, it has x, I'm missing x squared plus 1 to the second, plus b, x plus c is going to be multiplied by, I need another x squared plus 1, and I need x. And then for dx plus e, I need just x. Now, I don't know if you can tell, but just looking at this, it's not going to work as well to do the cover-up method that we just did in the other one before, because I have these linear terms. Those kind of make it more difficult, and I also have like x squared plus 1. There isn't anything to make that 0. So we are going to need to go on a coefficient hunt here. So let's expand these out. We're going to have 1 equals a times, and if I square this, I get x to the 4th plus x squared is 2x squared plus 1 plus, all right, now what I'm going to do here is I want to get b times something. So I'm really taking this whole thing here and multiplying it by that x to get what's multiplied by b. Because that's how you distribute, right? It'll be that times bx and that times c. So this is really x cubed plus x. So if I do x cubed plus x times x, I'm really getting x to the 4th plus x squared. That's what would be multiplied by b. If you're not sure about that, pause it, try it out yourself. You'll see that that's what you get. Okay, then I do the same but with c. So I want to go plus c times, this time it's just the x cubed plus x. Then I want d times, well, that would be just x squared, and plus e times would just be x. Okay, and then let's actually list out our coefficients here. We've got 1 equals what times x to the 4th? Let's see, I have a times x to the 4th, I have plus b, and that's it for x to the 4th. How about x cubed? I do have an x cubed right here, so that's plus c x cubed. What about x squared? I have a lot of x squareds. So we have 2a, I have b, and I have d. X squared. How about x? For x, it looks like I already did that, c plus e times x. And for my constant, I'm going to have A, and that looks like all. Okay, well, I don't have on the left side any terms other than the constant. So all these other coefficients are going to equal 0 when I write those equations. So I'm going to get an equation A plus B equals 0. I'm going to get an equation C equals 0. I get 2A plus B plus D equals 0. C plus E equals 0. And finally, A equals 1. Well, a lot of this I can solve pretty quickly. I see I have A equals 1, I have C equals 0. A little process of elimination here means that I also get E equals 0. What else do I know? If A is 1, then I know that B would equal -1. And I can plug in one last time here. 2A would be 2 plus -1 plus D equals 0. So D is going to equal -1. Okay, so then I've got to go back to my original up at the top. I'm zooming way out. And I'm going to write that I get A over X. Well, that's 1. So 1 over X plus BX plus C. So -X plus 0 over X squared plus 1 plus, and this will be over X squared plus 1 squared. I get dx plus e. That's -x plus 0 again. So there is my answer. All right, that's all. Thanks for watching.